Okay, here in section 3.6, the chain rule, and here in example 45, we want to just do several examples of the chain rule for you. So in part A, we're given y equals sine of x squared plus x. So we have an outside function, which is sine. The inside function is x squared plus x, right? This is f of g of x, where f of x is sine x, and g of x is x squared plus x. Just think of it as outside of inside, right? The outside function of the inside function. So the way you take the derivative of this is you take the derivative of the outside, which is the derivative of sine is cosine, evaluated at the inside. So the cosine of x squared plus x times the derivative of the inside, and the derivative of x squared plus x is 2x plus 1. Okay, again, I usually move that 2x plus 1 out in front because that's the proper way to write this. This times can be confusing here because it might look like this 2x plus 1 is times this x squared plus x, but it's not. All right, this is the argument of the cosine function, so you can't bring this 2x plus 1 in here. It goes in front. So it's 2x plus 1 times the cosine of x squared plus x. All right, g of t is the tangent of the quantity 5 minus sine of 2t. So my outside function is tangent, my inside function is 5 minus sine of 2t. So in this case, to take the derivative, g prime of t, I take the derivative of the outside function, derivative of tangent is secant squared, evaluated at the inside, 5 minus sine of 2t, times the derivative of the inside. Now the derivative of 5 is 0, so that's gone. But the derivative of the sine of 2t, now that's also a composite function, right? I got to take the derivative of that outside function, which is the derivative of minus sine is minus cosine of the inside function 2t, times the derivative of 2t, that inside function, which is 2. So this is a chain rule within a chain rule. Again, this is the argument of secant squared. This 5 minus sine of 2t is the argument of secant squared, so that cannot be multiplied times these guys, so I bring them out in front. So it's minus 2 times the cosine of 2t times the secant squared of the quantity 5 minus sine of 2t. All right, in our third part of this example, part C, we have f of x equals the quantity 5x cubed minus x to the fourth to the 7th power. So I think of my inside function here as being 5x cubed minus x to the fourth. My outside function is the quantity to the 7th, right? I hate to say x to the 7th because you get confused, but it's the outside function is this quantity here, but to the 7th power. That's the outside. So the derivative of this function, I take the derivative of the outside. That means I think of it as a power rule, right? I bring the 7 down, leave the inside alone to the 6th power. So 7 times 5x cubed minus 4 quantity to the 6th power times the derivative of the inside. That's the inside here. So the derivative of the inside is now 15x squared minus 4x cubed, just using the power rule on both of those pieces. Okay, now I could put that in front, but it doesn't matter because this 6th here is making sure that I don't multiply through anyways. All right, part D of this example, 1 over 3x minus 2, your first inclination might be, hey, use the quotient rule, which the quotient rule would actually work and you get the same answer. It's fine, because d high would be 0, right? Low d high, the derivative of 1 would be 0. So it would work, but it's easiest in this case, and now that you know the chain rule, to write this instead as 3x minus 2 to the minus 1 power. Now I employ the chain rule because I have an inside function, 3x minus 2. My outside is x to the minus 1, or this quantity to the minus 1. So I take the derivative of the outside, which is minus 1, leave the inside alone, to the minus 1, or minus 2, right? I'm just using the power rule there. Times the derivative of the inside, the derivative of 3x minus 2 is just 3. So now I can put this back into the denominator with a positive 2 power, so I get minus 3 over 3x minus 2 quantity squared. All right. Part E of this example, I have h of x equals sine to the 5th power of x, right? You have to be careful. This notation here, right, means this. It's the sine of x to the 5th power. It's the whole thing to the 5th power. So hopefully you're comfortable with that notation. You've probably seen sine squared x a lot, or cosine squared x. But if I have sine to the 5th of x, or sine 5th of x, it just means sine of x to the 5th power. So if I want to take the derivative of that, I need the chain rule, because I have an inside function and then an outside function, which would be x, or quantity to the 5th. So derivative of the outside first would be 5, leave the inside alone, to the 4th power, right? 5 minus 1. So there we go. Times the derivative of the inside, the derivative of sine of x is cosine of x. So there's my final answer, 5. I'm just bringing the cosine x, put it over here. 5 cosine of x times sine to the 4th of x, right? That's what this notation means again, putting it back in the more usual notation for that. And that's it for that example.